Hi everyone. Today we're going to work on finding a minimum sample size. So in other words, if you're going to go out and figure out, I want to find a population average of something, a population mean. How many things or people or bacteria do I need to sample to get the results that I want? Okay, so we're going to redo that, and it's really not too bad. We're going to use a pretty easy formula. So to find the minimum sample size to estimate a population mean mu, okay, with a given level of confidence, given a C% confidence interval, confidence level, and a margin of error. Okay, so this is your E. So in other words, I'm going to give you the distance from the the within part, or the E part is going to be within the problem. The minimum sample size N needed to estimate mu is N equals Z sub C omega over E quantity squared. Okay, so you want the Z score that corresponds with the confidence level, the standard deviation that's given to you in the problem, and the E, which is going to be the word within. So for the margin of error E, you're looking for the word within, because it's the distance that you want to be. It's the maximum amount of distance. Okay, so let's take a look at a problem. Okay, so a researcher wants to estimate the mean number of hours spent on requiring student athletes athletic activities at the student athletes at the athletic conference. How many student athletes must be included in the sample to be 95% confident that the sample mean would be within 0.5 of an hour of the population mean? And again, we're going to assume the population standard deviation is 2.3 hours. Okay, so key things here. Here's our C level. Okay, so C is 0.95. Our within, keyword there is 0.5. So there's your E. And our standard deviation is 2.3. Okay, so we have all the necessary information, but please, a lot of things that I see with this, guys, is that people just put 0.95 in for Z sub C. That is not right. You're using the Z score that corresponds with that confidence. So you got to go get it. So you have to go to either the formula sheet that I gave you, or it's on the bottom of the Z score chart. So our Z here is 95%, which I'm going to do 1.96. Okay. So we're going to go N, so our Z sub C is 1.96. So N is equal to 1.96 times 2.3 all over 0.5, quantity squared. Okay, don't forget to square your answer. All right, so do the math. Multiply the two together, divide by 0.5, and square it. I got 81.2. Now, we cannot have 81.2 people surveyed. Okay, that's just not how we're going to fly. So, always round up. So, one of the things we want to make sure is always round up. Okay? Can't tell you how many times to take points off because people don't round up. All right, so we need 82 student athletes. Let's try this again. So, student athletes researcher must include to be 95% sample. The confidence mean is within 0.75 of an hour. Suppose we change our within. Does that change how many people we need to talk to? All right, so we're still having a C level of 0.95. This time our E is 0.75. Our omega is still 2.3. Okay, so let's keep the same Z. 1.96 times 2.3 all over our 0.75, and then we're going to square that. Okay, so we're going to do the math. And I got 66 students. Again, that's rounded up. Okay, notice as we decrease the width of our confidence, we had to increase the amount of people we talked to. Okay, the wider the interval, the less students we have to talk to. Okay? All right, let's try some more. All right, cheese processing plant wants to estimate the mean cholesterol content of all of its 1 ounce cheese servings. Okay, types of cheese to estimate within the 1.75 grams of the population mean. Okay, we want to determine a sample with 95% confidence. Assume the population standard deviation is 3.1. Okay. All right, so let's see. We want our C level is 0.995, and I believe that's 1.96 is the Z. Our E is 0.75, and our omega is 3.10. Okay, so let's do N equals 1.96 times 3.1 all over 0.75, and then we're going to square that. Okay, so I get 65.6. We're going to round that to 66. Okay, types of cheese. Okay, so let's try another one. Sample mean is 29 milligrams. Use the minimum sample size with a 95% confidence level. Does it seem possible that the population mean could be within 3% of the sample mean? Within 0.3% of the sample mean. All right, so we have 29 milligrams, 3%, so 0.03. So let's see what that would be. All right, I got 0.87, and that would be the E, okay, within that much. And no, because it was 0.75. Let's do the other one. So 0.3% would be 0.003. Okay, I got 0.087. Yes, because that's smaller than 0.75. Okay, so that's an extension of working the N problems. Let me know if you have any questions, guys. By the way, this should be C because we're doing our 3rd day of confidence intervals. Have a great rest of your day. Let me know if you have any questions. And remember, we're going to stay safe by staying in.